Good day, everyone. So we want to start with the aspect of the mathematical economics, where we are going to be examining some outline under mathematical economics that ranges from indices. We have indices, we have logarithm, we have sequences and series, permutation and combination, we have set theory, complex number, equations that range from simultaneous quadratic equations, etc. So we are going to be starting with indices, which is the first topic. So this series we are going to be dealing with indices. Yeah, when we talk about indices, what are we saying? Indices come from the index form. Now, from example, when we have 2 times 2 times 2 times 2, we said it is equals to 2 times 2 times 2 times 2, we said it's equals to 16. Now, instead of having it this way, we take two indices. Instead of having 2 times 2 times 2, for the case of when we have a large number of times we are going to be multiplying the 2, it's just the same thing as 2 raised to power the number of times which the 2 is repeated, with the same thing as 2 raised to power 4. That this 2 raised to power 4 is 2 times 2 times 2 times 2, which is the same thing as what? 16. So that's where we come from, and we have what's called the aspect of the indices. And when we're talking about indices, there are laws that are guiding indices, ranging from the multiplication law. Now that's the first law, and the multiplication law states that when we have indices of the same base in multiplication form, you add the power. When you have indices of the same base in multiplication form, you add the power. What do you mean by that? If I have a raised to power m multiplied by a raised to power n, the law says we have a raised to power m plus n. Now if you look at it, this is the power. M and n serve as the power, while a is the base. So you take one of the base, then you do what? You add the power. That is what the multiplication law says. So in numerical form, if I have 2 raised to power 3 multiplied by 2 raised to power 2, the law says you have 2 raised to power 3 plus 2, and that will give you 2 raised to power 5. That's for multiplication law. And the law number 2 is the division law. Division law. And this law states that what? When you have indices of the same base in division form, subtract the power from each other. So, in multiplication, you said you add the power. Now in division, we are subtracting the power. That is, you have a raised to power m divided by a raised to power n is the same thing as a raised to power m minus n. At the same time, you can see after division of this form, a raised to power m divided by a raised to power n, still the same thing, you have a raised to power m minus n. And numerically, you have this as 2 raised to power 3 divided by 2 raised to power 2, and that gives 2 raised to power 3 minus 2, which is 2 raised to power 1. That's for the division law. The power law. And in this situation, when you have an indices, there's raised to, when you have indices, obviously there's a base and there's a power. And you now have another power outside the bracket. What the law says is you use the two powers to multiply each other. For example, if you have a raised to power n, open and close bracket raised to power of m, the law says you have what? A raised to power n multiplied by m. That is, you use the two power to multiply each other. Numerically, if I have 2 raised to power 3, all raised to power of 2, what the law is saying is I have 2 raised to power of 3 multiplied by 2, and that gives me 2 raised to power of 6. That's for the power law. Then the next law that we have is the root law. We have the root law. Now, in this law, it's also whereby you have a square root or an nth root of a particular indices. For example, you have nth root of A. Nth root of A, the law says you have it as A raised to power reciprocal of the root. Nth root of A, then it's the same thing as A raised to power what? 1 over n, the reciprocal of n. So if I have now square root of 4, it's the same thing as 2 raised to power 1 over 2, because we know, everybody knows that root is what? 1 over 2. So that is why we have 4 raised to power 1 over 2. And that's for the root law. Next law, we have the power root law. So at the same time, we've seen the power law, we've seen the root law. So at the same time, there are situations whereby you have both the power and the root at the same time with an indices. For example, you have nth root of A raised to power m. What the law says here is, you are going to apply the root law when the nth root is going to be serving at the denominator and the power will serve at the numerator. That is, we have A raised to power m over n. Or to simplify it more, we can have it as A raised to power 1 over n, all raised to power m. Applying the power law into this place, then we have A raised to power m over n, which is the same thing as what you have in this place. So in the situation whereby you have both the power and the root on an indices, the power will serve at the numerator while the root will serve at the denominator, and both will serve at the power of the indices. For example, if I have cube root of 8 all raised to power of 2. For example, cube root of 8 all raised to power of 2. Ordinarily, you have 8 raised to power of 1 over 3. That's the cube root of 8 all raised to power of 2. By applying the power law, we have 8 raised to power 2 over 3. Then you simplify further there. So the next one is the zero law. We have the zero law, which states that anything raised to power of 0 is equal to a unit, which is 1. That is, if I have A raised to power 0 is the same thing as 1. If I have 10 raised to power of 0 is the same thing as 1. If I have 100 raised to power of 0, it is 1. That is, anything that has 0 as the power is equal to a unit, 1. The next law is the reciprocal law, or we call it inverse. For example, when you have A raised to power minus m, the law says it's the same thing as 1 over A raised to power m. That's inverse, the reciprocal of it. 1 over A raised to power m. That is, if you have 2 raised to power minus 3, it's the same thing as 1 over 2 raised to power 3 in indices. It's the reciprocal law. And if you have an odd number and you have to find the reciprocal of the odd number, for example 5, reciprocal of 5 is 1 over 5. Reciprocal of A is 1 over A. So as you have examined all the laws, we are going to apply the laws. We are going to take some examples, like 2 or 3 examples on indices, and we're going to be applying the laws on them. We're going to be starting with the first example. This one looks more simpler, and I think one hint I want to drop for us on this is most often when you have indices question of this nature, first thing you need to look at is what is common, what is the common factor to all the values you are given in the question you want to simplify. So we want to simplify the following. So now if you look at the first question we want to look at, if you look at this 8 is a factor of 2, 64 is a factor of 2, 16 is a factor of 2. So from there, now solution. So we have 8 divided by 64, divided by 16, multiplied by 2 raised to the power of 4. So 8 is something as 2 raised to the power of 3, divided by 64, that's 2 raised to the power 6, divided by 16, which is 2 raised to the power of 4, multiplied by 2 raised to the power of 3. Now let's apply the law. For the numerator we have the division law, and now we have 2 raised to the power 3 minus 6 divided by, at the denominator, that is a multiplication law, that's addition, 2 raised to the power 4 plus 3, 2 raised to the power minus 3 divided by 2 raised to the power 7. Now we still need to apply the division law once again. So we have 2 raised to the power of minus 3 minus 7. And that gives us 2 raised to the power minus 10. And by applying the reciprocal law to the answer, we have 1 over 2 raised to the power 10 as the final answer. So that's for the first example. Now looking at the second example, where we have 3 raised to the power 3 plus x divided by 27 raised to the power 1 plus x equals 9. Now if you look at this, we discover the other factor of 3. So we have 3 raised to the power 3 plus x divided by 27 is 3 raised to the power of 3 into 1 plus x, and 9 is same thing as 3 raised to the power of 2. So here we continue. 3 raised to the power 3 plus x divided by, you open the brackets at the power, 3 raised to the power 3 plus 3x equals 3 raised to the power of 2. Here we apply the division law. Then we have 3 raised to the power 3 plus x minus 3 plus 3x equals 3 raised to the power of 2. I use the bracket so that there's not going to be any confusion. You know, the division law says we should subtract. So it is always good for you to first apply the bracket so that you use the negative sign to open the bracket. There you will not make any mistake. So we have 3 raised to the power 3 plus x minus 3, that's minus x plus. Then minus x plus again is minus 3x equals 3 raised to the power of 2. So from here, 3 minus 3 is equals to 0. So we have 3 raised to the power x minus 3x to give us minus 2x equals 3 raised to the power of 2. Now from here, power, by striking out the two power, since they are having the same power, and there's an equal to in between them. So that means we have minus 2x equals to 2. Then you divide both sides by minus 2 to make x subject of the relation. So that means you have x equals 2 divided by minus 2, which is equals to minus 1. So the value of x is equals to minus 1. Now I can as well show you that when you have something of this nature, for you to be sure that your answer is correct or not, you can cross-check by substituting the value of x into the question you are given. So the question we are given is 3 raised to the power 3 plus x divided by 27 raised to the power 1 plus x equals to 9. So you can check if your answer is correct, it's a confidence, we call it confidence level. To know, oh yes, I have the confidence that the answer I got here is correct. So what you need to do is to substitute the value of x you got into the question and see if the left hand side will be equal to the right hand side. So here we have 3 raised to the power 3 minus 1, since x is minus 1 and minus times plus is minus, divided by 27 raised to the power 1 minus 1 equals to 9. So we have 3 raised to the power of 2, that's 3 minus 1 will give you 2, divided by 27 raised to the power 0 equals 9. If you remember, we said n raised to the power of 0 is what? Is equal to 1. So we have 3 raised to the power of 2 divided by 1 equals 9. And when you divide anything by 1, you are still going to have what? So it's the same thing as when you said you have 3 raised to the power 2 divided by 3 raised to the power 0 equals 9. And that gives you 3 raised to the power 2 minus 0 equals 9. 3 raised to the power 2 is equals to 9. 3 raised to the power 2 is the same thing as 9. And 9 is equals to what? 9 is equals to 9. So that's just all the answer we have is correct. So let's solve the third. So this example number 3, we have this. Let's look how we are still going to apply the law. The best thing to do in solving all these indices is just make sure you apply the law and you follow it step by step. There is no how you will not arrive at the answer. So we have 3 raised to the power x divided by, now 1 over 27 is the same thing as reciprocal of 27, which will give you what? 27 raised to the power minus 1. All raised to the power of 1 plus x equals 3 raised to the power 2. Now, this has turned into power law. What you need to do is what? Use the two powers to multiply each other. So we have 3 raised to the power x divided by 27 raised to the power minus 1 minus x. Because minus times plus is minus, minus times plus will give minus. Then we have 3 raised to the power of 2. So again we go 3 raised to the power x divided by 27 is the same thing as 3 raised to the power of 3. You have minus 1 minus x equals 3 raised to the power of 2. Then you have 3 raised to the power x divided by applying the power law, we have 3 raised to the power minus 3 minus 3x equals 3 raised to the power of 2. So applying the division law at this left hand side, we have 3 raised to the power x minus 3 minus 3x equals 3 raised to the power of 2. 3 raised to the power x plus 3 plus 3x equals 3 raised to the power 2. Equate the power. Then you have x plus 3 plus 3x is equals to 2. Collect the like terms. So x plus 3x equals 2 minus 3. 4x equals minus 1. Then we divide both sides by 4. 4x divided by 4 minus 1 divided by 4. This will go with this. Then x is minus 1 over 4.